Hello everyone, let's review for our very short unit rationals test tomorrow. You guys should do very well on this. We're just reviewing a couple of the ideas here. First of all, end behavior. There are 1, 2, 3, 4, 5, 6 places this function leaves the page, the graph that I have. So let's first focus on those two. And this is, I'll sort them just by asymptote. This is the x equals 1 asymptote. And you can see that it goes up. So we're saying y goes to infinity as you get closer and closer to 1. And this function is on the left side, so we say on the left. It's going up as you're on the left side of the asymptote. And down here, it's going down, so we say negative infinity, 1 from the right, on the right side of the function. The other asymptote I have is at 2, so I'll now do that one. When x equals 2, I have another vertical asymptote, x equals 2. And again, you can see that it's going up right here on the right side. So it's over here on the right. So we say 2 with a plus sign. And here it's going down, so negative infinity. And that's on the left side, so 2 with a minus. And the last one I think is the easiest. It looks like the horizontal asymptote is y equals 0. So this is y equals 0. The y values are both getting closer and closer to 0. Even if it crosses through it, it's just going to level off at 0. It doesn't matter which way you go. If you go to the right, x goes to infinity, or you go to the left, y is going to level off on the x-axis. That's y equals 0. Next up, we got to analyze some functions. So first thing, the x-intercept is when the numerator is 0. If you factor this, let's see, it would be plus 5 plus 1. If you factor it in the top, it's going to be minus 2x minus 1 and x minus 5. So that way you get negative 11. And then in the bottom, you got x minus 4. So where are the x-intercepts? When the numerator equals 0, 1/2, and 5. And I want to write those as ordered pairs. Vertical asymptote, when the denominator equals 0, x equals 4. Y-intercept, if you plug in 0, you get 5 over 4, so 0, negative 5 over 4. And the slant asymptote requires that we do long division, so I'm going to write that out. 2x squared minus 11x plus 5, and I'm going to divide x minus 4. So for long division, x times 2x will get you 2x squared. Distribute, 2x squared minus 8x. Minus plus cancel. Negative 3x plus 5, and then the last thing I need to do is x times negative 3. So that's negative 3x plus 12, which when you flip the signs, you get a remainder of negative 7. But I don't care about the remainder. The slant asymptote is this, y equals 2x minus 3. So I'm going to start by graphing that. 2x minus 3, start here. The y-intercept is negative 3. Go up 2 over 1. So this is the slant asymptote. Okay, I'll draw the vertical asymptote, x equals 4, 1, 2, 3, 4. And we're going to be boxed in here by these asymptotes. So the x-intercept is 1/2, and the other one is 5, 1, 2, 3, 4, 5, right that. And the y-intercept is negative 5/4, which is about right there. So the asymptotes tell us the end behavior. It's going to follow along the slant asymptote, and then it's got to eventually go up and just run into this vertical asymptote. And then same thing on this side, up to the slant and down along the vertical asymptote. That wasn't my best effort, but looks okay. Did I have that graphed? I do have that graphed right here. Okay, so that's the function. See, it doesn't look great here either. But if I try and graph the slant asymptote, 2x minus 3, you can see how it fits in there, and the end behavior starts to approach that asymptote. So kind of cool. Let's try another one. X-intercepts, so factor the top, x minus 4, x plus 1. I'll factor the bottom while I'm at it, just GCF. X minus 3. So the x-intercepts are going to be at 4, 0, and negative 1, 0. The y-intercept, wait a minute. Let's find vertical asymptotes first. X equals 0, x equals 3. 0 and 3. Now, the fact that x equals 0 is a vertical asymptote means you can't plug in 0 because the y-axis is a vertical asymptote, so there is no y-intercept. Horizontal asymptote, they have the same degree, so 1 and 1. So you divide, and you get y equals 1. So I have vertical asymptotes at 0 and 3, and then horizontal asymptote y equals 1. Oops, that's not an eraser. Okay, so we got this. Now, this one's going to be trickier to draw. We didn't, 2, 3, 4, spend a ton of time doing this, but we could probably figure out. You're boxed in by these asymptotes, so it's going to follow this guy, and it's going to go down. Well, that wasn't great. Come on, do better. That's okay. Same thing here. Boxed in by the asymptotes, you just can't go through that vertical asymptote. This part, though, to figure out the middle, we didn't talk a lot about that, but since there's no x-intercept, I don't think it's going to do that. It could, but I think it's going to do this. Okay. So what I'll do is I'll just look at my graph and see. There you go. You see how it's in the middle? Looks like that. Okay. So again, we didn't spend a lot of time doing these graphs, but that is pretty close. That's pretty good. Last one, I always factor out the negative if the leading coefficient is negative. And then in the denominator, you have x minus 3, x minus 1. Ooh, removable discontinuity. Okay. So we have a hole at 1. We have an x-intercept at, there is no x-intercept because it's removed. Okay, it would be an x-intercept, but it's removed. Let's see, vertical asymptote is x equals 3. The y-intercept is 0, 2/3. And since this thing is bottom heavy, the horizontal asymptote is y equals 0. So you can see the x-axis is an asymptote. And you could still have an x-intercept. We just don't. The vertical asymptote is 3. And we know the y-intercept is 2/3. So that's about here. So you can see we're kind of controlled by these asymptotes. It's going to go up and over. And then down here, again, I just know it's going to look like this. Okay, because they're diagonal from each other. There's no multiplicity in here. So if I look at that one, yep, looks like that. And at 1, well, you have a vertical asymptote at 1, so there is no, wait, what? Is that the right graph? Oh, that's at 3. The vertical asymptote's at 3. 1 should be a hole, right? There, right there. Good, there is a hole at 1. So I could put that on my graph. 1, 0, there's an open circle. Okay. All right. If you can analyze these things algebraically, don't worry so much about drawing the graph. You're going to be just fine. So that's all you need to do, and make sure you hit that like and subscribe.